All right, here we go. A sequence. Is that what I want? I think that's what I want. A sequence is a set of numbers called the terms of the sequence. So the first number is the first term, the second number is the second term, the third number is the third term. But they're in a specific order. Since the difference between each successive term is constant. Now there's a lot of vocab there. The difference or the change between each successive term, which means every number in a row, is constant. Constant means the same. This is an arithmetic sequence, arithmetic. Now, a big discussion between the math teachers yesterday. We had a meeting. I said, okay, do you say arithmetic or do you say arithmetic? And we all kind of went different ways. If I just say like, oh yeah, they were doing arithmetic. Nobody really says that. You say you're doing math. I say arithmetic. But for some reason, when it's sequences, I say arithmetic because I don't like arithmetic sequences. It sounds weird to me. So whether you say arithmetic or you say arithmetic, technically they're the same thing. Okay? The difference, or in other words, the change between the terms is called the common difference. Difference usually in math means subtraction. So we're going to subtract the two numbers to find what the change is. Here you go. Here's a little ELA for you. The three dots used with sequences is called an nicely done. Ellipses. ELLIPSIS. I think is how you spell it. That's not really something you have to know for math, but it does mean something. This indicates that there are more terms in the sequence that are not listed. It's basically a way of saying this never ends. It goes on and on forever.
Oh,
okay.
That's a symbol for that, isn't there?
An ellipsis. Dot.
Yeah, you put it over the, no, like on a decimal. You get like 2.33333, you can just go 2.33, put the line on top of it.
That's for a repeating number. Okay, I'm going to go back to what I just taught you. The three dots are used with sequences are called ellipses. This indicates there are more terms in the sequence that are not listed. They are not the same. There are just more terms. Determine whether each sequence is arithmetic and explain. If it's an arithmetic sequence, we have to add or subtract only, and it has to be the same that I add or subtract between every number. So, how do I go from 4 to -2? Add 2. How do I go from -2 to 0? And 0 to 2. Is this arithmetic then? Yes. And we say the common difference is +2. And I know that seems really weird to say a common difference is a positive number. But the difference is like the change is a +2. Go to the right. -26 to -22. -22 to -18. -18 to -14. Is this arithmetic? Yes. The common difference is +4. The common difference is +4. Okay? 1/2, 5/8, 3/4, 5/16. I don't want to convert these to decimals. The only way we can figure out is if we are adding or subtracting the same amount with fractions is to have a common denominator. What is my common denominator going to be between 2, 8, 4, and 16? 16. Okay? So 1/2 is 8 over 16. 5/8 is 10 over 16. 3/4 is 12 over 16. And 5/16 is 5/16. Okay. How do I go from 8/16 to 10/16? plus 2/16. That is not 1/4. 10/16 to 12/16 plus 2/16. 12/16 to 5/16. Subtract 7/16. Is this an arithmetic sequence? No. And all you have to say is no. This proves it right here. You added, and then we subtracted. Who cares how much they added or subtracted? The fact that it changed makes a difference. Try that last one on your own. If I gave you the sequence 1, 4, 9, 25, you determine if it's arithmetic. Is this arithmetic? No. 1 to 4 would be +3. 4 to 5 is +5. 9 to 25 is +16. Okay? Not arithmetic. Not adding or subtracting the same amount. Question? Okay? It's not necessarily that if there's a pattern. There is a pattern to this. Does anybody know the next number in this? 1, 4, 9, 25, 36, 49, 64. It's all your squares, right? 1 squared, 2 squared, 3 squared. Oh, we skipped 4, so that doesn't really work. Okay? So there could be a pattern to this, but it's not arithmetic. We're not adding or subtracting the same amount. So let's just make sure we understand arithmetic sequences. All we have to do now is find the next 3 terms of the arithmetic sequence. So they start it for us. 15, 9, 3, -3, -9, -15, -21. What was your pattern? They subtracted 6 every time. Very good. 9.5, 11.0, 12.5, 14.0, 15.5, 17.0, 18.5. What's the difference in that one? 1.5. Very good. And follow, you guys did a good job. 17.0. They put that 0.0 on there. Follow their lead. Okay? And you're like, sweet. I can add or subtract all day long, right? Miss Hoff can't subtract to save her life, but she can add. All right? The difference with this, or what we're going to be working to now, is every term in an arithmetic sequence, so every number in an arithmetic sequence, can be written in terms of the first and the difference. What's going to happen today is they're going to say, find the 57th term in this sequence. And I don't know about you guys, but I don't want to have to write out 57 terms. Agreed? Okay, so bear with me. A1 is the first term in the sequence. It is the very first number in the sequence. D is the common difference, the number that you add or subtract. It may be positive, it may be negative, based on whether it's positive or negative you're adding or subtracting. Okay, we're going to fill this out. I'm going to give you a sequence. This is weird how we're going to fill this chart out. Go to the number side. We're going to say that our first number is 7. Okay, we locate this, or we write this as a symbol as A1. I should probably give you a sequence first. Let's write this sequence down. 7, 10, 13, 16, ... Okay. How do you think I represent the second term as a symbol? A of 2, very good. Arithmetic sequence, second term. That A stands for your sequence. Now, they want us to write this number in terms of A1 and D. We're going to come back to this. Go to the numbers. How could I represent my number 10 by using only the first number and the common difference? What's our first number? 7. What's our common difference? 3, right? And everybody agrees 7 plus 3 would give me 10. Everybody follow me so far? Okay. So 7 we said was really A1, agreed? So if we took A1 and we added the common difference to it, everybody follow me so far? 7 plus my common difference of 3 gave me the second number 10. Good? Okay, what's my third term? Or sorry, what's the symbol for my third term? A of 3. Now we're going to jump over here to numbers. What is the actual number of my third term? 13. I need to represent 13 by only using 7 and 3. Jackson.
7 plus 3 in time, 3 times.
Like this? What are you guys' thoughts? Is he correct? 7 plus 3 times 2. Order of operations, what would I do first? Multiply. 3 times 2 is plus 7 is spot on. Now here's the deal. Now I want to write this in symbols. I want to write exactly what he just did in symbols. What replaces 7? A1 plus D times 2. What I hate is that he put the 2 behind it. Do you hate that? So are you guys good if I write 2D? Follow that? All right, fourth term as a symbol would be A of 4. Go over here to numbers. What is my fourth term? 16. I need to write 16 using only 7 and 3. Thoughts? 7 plus 3 times 3. 3 times 3 is, plus 7 is 16. Nicely done. So we go back here. How would I write it in symbol format? A1 plus 3D. Do you notice a pattern? If I put another one in here that said the fifth term would be A of 5, and it would equal A1 plus 4D. Okay, very good. So now they want us to do the nth term, meaning you pick a number, the 57th term, the 12th term, the 172nd term. So A of n. N is a number. We can put any number in there. I can find any place in line. How? Fill this out for me. Any number. You guys figured out the second one would be A of 1 plus D. The third one would be A of 1 plus 2D. The fourth one would be A of 1 plus 3D. You just did out loud. The fifth term would be A of 1 plus 4D. Now, what if I say I want the nth term, meaning any random number I pick? How could I represent that equation using A1 and D? Meg. What does n minus 1 mean? Right before it, right? When we were on the fourth term, we only needed 3 of our common differences. If I'm going to be on the 27th term, how many common differences do I need? 26. Okay? So you always take away 1 from your n. And everybody's like, that's really complex. Here's the deal. Am I ever going to make you fill this form out again? No. But what you just did, bless you, is you found the formula you're going to use today. You just wrote that. So if I want to find the arithmetic sequence, A of n equals A of 1 plus n minus 1 times D. Now, some people will go like this. They'll put D first. Isn't it funny when Jackson wrote the number behind it, we didn't like it, but now this way we would rather have the D in front of it? Do you agree with that? Like just how our brains work with the letters that we have. These mean the same thing because you're multiplying. As a reminder, A of 1 is your first term. So you're always going to replace A of 1 with a number. And you're always going to replace D with the common difference. But here's the deal. Every single one of your equations today, n minus 1 stays just n minus 1. You don't know the number. It stays A of n. We're writing an equation that anybody could pick any n value. Okay? And it's still kind of like, I kind of get it, but I'm still a little foggy, right? Flip it over. Let's put it into use then. So here it is. Write an equation for the nth term, meaning any term for the arithmetic sequence. So write this down with me. A of n equals A of 1 plus n minus 1 times d. There's two things we have to fill in here. What are they? D and A1. So A of n stays. A of 1 is negative 12 plus n minus 1 times plus 4, a positive 4, right? Now, I hate how that looks. And I put the 4 in parentheses, but many of you didn't. This is where I say, I put the common difference in front of that parenthesis. A of n equals negative 12 plus 4 times n minus 1. That's all you have to do. That's it. That is the equation. That is the equation for the nth term of the sequence.
If we wrote the 4 like on the opposite side of like that would change or like.
No, but I would just make sure to put the 4 in parentheses to make sure that it's multiplication. 100%. Technically, either one of these is correct. I just hate that 4 in the back of it. Okay? I'm going to tell you, if you get this wrong on Alex, Alex is going to say, sorry, you're wrong. The answer is actually A of n equals 4n minus 16. What did Alex do to get that? And what do you mean by simplify? You're right, Sophia. What did they do? Yeah, they distributed it and combined like terms, right? Now, here's the deal that I'm going to tell you. If you type this incorrectly, it won't count it wrong. It's not counting it wrong because you didn't simplify. It's counting it wrong because either your first term or your common difference is wrong, okay? So it will take that answer that I have boxed in up there as long as you have it typed in correctly. So many people are like, oh, you said we didn't have to simplify, and Alex says we do. Alex automatically defaults to that. Ms. Hoff says, why distribute if we don't have to make that mistake? Agreed? Why go through that if we don't have to?
But when we enter Alex, we have to distribute.
You guys help him.
No, Jess, you don't. You can leave it the same.
Why would it count it wrong? You did it wrong. You did it wrong. It's not because you didn't distribute. It's because you typed it in wrong. Okay. Sticking with that same sequence. Now they say they want you to find the 9th term. That means n equals 9. So take your equation and plug in 9. A of 9 equals negative 12 plus 4, parenthesis, 9 minus 1. Order of operations. What do I do first? 9 minus 1 is 8. So I have negative 12 plus 4 times 8. Now what do I do? 4 times 8, which is, whoopsies, I heard you say 32 and wrote 3. Negative 12 plus 32 is 20. Guess what the 9th number in that sequence is? 20. I don't know about you, but if I don't have to write out 9 numbers, I don't want to. Now, sticking with that same sequence, They want to know which term is 32. In other words, which place in order, when you wrote that out, does number 32 occur? They want to know where is that number. In this case, we are trying to find n. So we take our original equation, shrink this down. We take our original equation. This time I know what the number is. I need to find n. So I'm going to say 32 equals negative 12 plus 4 times n minus 1. Everybody follow the difference between the two problems we just did. This one tells us the term. The word term means n. They're telling us n is 9. On this one, they're saying which term, meaning we don't know what n is. We need to find n. See the difference in the two? Okay, so if I take this equation on the right, now I'm solving for n. Think back to chapter 2. First thing I should do, distribute. What am I distributing? 4. So leave your negative 12. 4 times n, 4n. 4 times negative 1, negative 4. What should I do next? What are your like terms? Which give you negative 16 plus 4n. Then I should add 16. 32 plus 16, 48 equals 4n. And last but not least, divide by 4. What term is 32? The 12th. The 12th term. The 12th number in order is 32. We're going to do this all over again. Okay? I'm going to give you a little leniency, and then I'm going to check in with you. Okay? You on your own, do part A for me. Take 3, negative 10, negative 13, negative 36, and write the equation for the nth term, just like we did part 1 at the top. Then stop. Don't go any further. A of n equals 3 minus 13 parenthesis n minus 1. Why is it minus 13? It's supposed to be plus d. Plus a negative 13. Do we ever want to write both plus and a negative? No, Ms. Hoff would go crazy, right? So your d, in this case, the common difference is a negative 13. And here's where I'm going to go back to what Riley asked me. Could I put that d after n minus 1? You absolutely could, but this is one that if you don't have 13 in parentheses, it looks like a negative 13. Does that make sense? So I would, not that it's wrong, I would just avoid it and use this one. Okay? Questions so far? All right. Now take what we just wrote and find me the 15th term. If I wrote that sequence out for 15 numbers, what is my 15th term? Am I right? Negative 179?
Yes.
Yes? That's a lot of subtraction for Ms. Hoff right there, so I'm just checking. Okay? Now, which term of the sequence is negative 114? Now, I don't know what n is. This is where negative 114 is what my equation equals to. So negative 114 equals 3 minus 13 times n minus 1. See what you get. What'd you get? I got 10. Yes? Check your work. I got 10. Not saying I'm not wrong. I think I'm correct. As I walk around, some of you lost your negative on your 13. So when you divided this, you would have gotten a negative n, or n to be a negative term value. Should that have been alarming? That would have been like before the sequence started, right? So your n value should always be positive. Do more people agree with me that it's 10? Yes? Okay. Biggest thing today, we got to watch, are they asking what term or what is the value at a certain term? Okay? Scratch paper or the paper with the boxes in the back. 3-5 online is open. Tomorrow's an activity in class. Thursday is a review. Friday is a test. First online test for Ms. Hoff. We'll talk about the details of that more tomorrow.